Hello, welcome to ANS Solver. This is the second question of the paper. So as you can see, cars arrive at a filling station randomly at a constant average at 2.4 cars per minute. That means this suggests that my lambda is 2.4. I need to calculate a probability that 4 cars arrive in a 2-minute period. Fewer than 4 cars arrive in a 2-minute period. So first thing, if you see, I can write minutes here. I can write lambda here. For 1 minute, okay, my lambda was 2.4. Now I have 2 minutes, so my lambda is basically 4.8. Okay, now I basically need fewer than 4 cars, so I need the probability of x being fewer than 4 cars, which basically means the probability of x equals to 0 plus the probability of x equals to 1 plus the probability of x equals to 2 plus the probability of x equals to 3. Now my formula of Poisson is simply e raised to minus lambda into lambda raised to x over x factorial. So using this, what I can do is I can write this as e raised to minus 4.8 plus e raised to minus 4.8 into 4.8 plus e raised to minus 4.8 into 4.8 raised to 2 over 2 factorial plus e raised to minus 4.8 into 4.8 raised to 3 over 3 factorial. Okay, so now I know this is a very big thing to solve on the calc. I can tell you a simpler method. What you can do is on the calculator, okay, what you can simply do is click on shift and then click on log with the button something like this. When you do that, you get on a display a summation sign like this with a box here and a bracket here. If you see, we are calculating the summation from 0 to 3. So what I simply do is I write 0 here, I write 3 here. So I get e raised to minus 4.8 into 4.8 raised to x over x factorial. X basically takes all the values from 0 to 3. Okay? And to write an x, you simply need to click on alpha and the closing bracket button. Okay? So simply do that on a calc. Even I'm doing it. Okay? So yeah, when you solve this, you basically get your answer when you click on equal to as 0.294, which is basically the final answer of the question. So it's really important you write all the steps till here, but when you solve on the calc, you can use this method. It's way more faster than writing the full thing. Now use a suitable approximating distribution to calculate the probability that at least 140 cars arrive in a 1 hour period. So now if you see, I can write minutes here. Okay, I can write lambda here. In 1 minute, my lambda which I had is 2.4. Now 1 hour consists of 60 minutes. So I can simply do 60 into 2.4, which gives me 144. Now, if you remember your conditions, you know the Poisson can be converted to normal, which will look something like lambda comma lambda, because in normal distribution it's always mean comma variance, correct? The condition, the prime condition here is basically your lambda should be more than 15. And if you see here, 144 is more than 15. Okay? So now what I need to do is, I need to calculate the probability that there are at least gives me the indication that this is more than equal to. So I can write this as x as more than equal to 140. Okay? Now see, there'll be a small catch of continuity correction here. When the time comes, I'll tell you how to deal with it. Okay? So now, if you have a normal distribution curve, something like this, I know this can basically be written as normally with 144, comma 144, correct? Because lambda, comma lambda. So I know my mean is 144. The value I have is 140. Okay? Now I simply need more than equal to 140. So I basically need the area here. Correct? Now I know my formula is basically z equals to the value minus the mean, which is the lambda, over the square root of the variance, because standard deviation is basically square root of variance and my variance here is lambda. But now what will be your value? Will it be 140? No. You need to know, when you convert from Poisson to normal, you are converting basically from a discrete variable to a continuous variable. So there's a very important thing which comes of continuity correction, which you need to know. Okay? So basically, if I have 140 here and its sign is more than equal to, the continuity correction is always of 0.5. If it's more than equal to, then it's minus 0.5. So I can simply write this as 139.5. So I can write this basically as z equals to 139.5 minus the lambda, which is 144, over the root of 144. So I can calculate the z here. So 139.5 minus 144 over the square root of 144. So when I do that, I get my value basically as minus 0.375. Now as you can see, we need more than of that value. So we do 1 minus the phi of minus 0.375. So to calculate this, I can simply use my calc. So on the calculator, what you can simply do is click on mode, then click on 3 where stat is written, then click on AC, then click on shift, then on 1, and then click on 5. When you do that on a display, you get 1P, 2Q, 3R, and 4T. So now if you see, you need to know option 1 and 3. 2 and 4 are not that important. P basically means less than of the Z value basically. Okay? And R basically means more than of the Z value. Here we are calculating more than because of 1 minus phi. So I simply click on option 3. So when I click on 3, I get R with a bracket like this. So here I simply put minus 0.375. Okay, so when I do that and I click on equal to, I get my answer as 0.646, which is basically the final answer of the question.